Okay, this is the online study guide for the big algebra test coming up. The test covers both linear equations and polynomials. Mostly, though, it focuses on the new chapter, which is linear equations. And we'll start with a type 1 equation. You learned how to do type 1 equations back in grade 7. The only complication we had here in grade 9 is that we used your decimal skills. And let's see, we look at this and go, we have to divide both sides of this equation by 0.08. And we know that if we do that, well, we know that 8 goes into 4.86, or we know 8 goes into 48 6 times. So it would go into 4.8.6 times. But then, of course, this isn't an 8. It's got 2 decimals on it. So you'd shuffle the decimal over. Of course, you are allowed a calculator on an algebra test. So if you put in 4.8, make it negative, and divide by 0.08, you get the answer of negative 60. So x is equal to negative 60. Okay? You should, of course, know how to verify or do a check. If it asks you for that on the test, then that's worth a mark. So plug in your negative 60, and again, run it through the calculator to prove that both sides do equal the same number. Let's move on next to a type 2 equation. This equation I would solve in 2 steps. Step 1 is I add 7 to both sides. And in the second step, I divide both sides of the equation by this coefficient here, which is 5/3. And don't forget that to divide by a fraction, you really times by the reciprocal of the fraction, giving me 39/5. Now, there is another way to approach this question. You could turn it into a type 3 equation and do it in 3 steps. If you want to think of 5x over 3 as literally 2 steps, timesing by 5 and dividing by 3, in which case the first step's the same. Add 7 to both sides. But then I'll times both sides by 3, divide both sides by 5, and get the answer. And again, using your scientific calculator, you should be able to do this calculation. Oops, sorry. This calculation to prove that this side does equal 6. And remember that when you're doing this, you can use your fraction button that most of you have on your calculators, or you could just turn this into a decimal and prove that the 2 sides are the same. Here's one where I might choose a different strategy. I can again work with the fractions and get common denominators, or I can find my common denominator, lowest common denominator, of 2, 3, and 4, and simply multiply the entire equation by that number. The lowest common denominator of 2, 3, and 4 is 12. So I would times each of these numbers by 12. And if I do that, 2 goes into 12 6 times, leaving me 18x, since 6 times 3 is 18. 4 goes into 12 3 times. 3 goes into 12 4 times. And then I would solve the way I always solve a type 2 equation. And don't panic when your answer doesn't look like a nice whole number or a nice whole integer. Very often in grade 9, we engineer the questions that way just to see if you can work with the fractions. Remember, we don't really want a decimal answer in this unless there's a reason why we want a decimal. Like, for example, if the question had started with decimals, or this was a word problem where a decimal answer is more appropriate. Most of the time, we prefer you just leave it as a simplified improper fraction. And of course, you could take your calculator and show that 3 times 23/18 minus a quarter would equal 5/3. My Windows calculator doesn't do fractions very well, so I'll just do them as divides. So 3 times 23 over 18 divided again by 2 minus 1 divided by 4 for a quarter equals 1.6 repeating. And that's what 5/3 is. It's 1 2/3. 5 divided by 3, same thing. They're both 1 2/3. So verified. We know we got the right answer. Moving on to type 3. Here's where the real grade 9 algebra starts, because now we have x on both sides of the equation. You might even call this type 4. It's kind of a 4-step equation. And what I have to do is I have to, first of all, distribute my x into the bracket, or my 5 into the bracket, and distribute my 2 into this bracket. Then I'm going to add 4x to both sides. Then I'm going to add 5 to both sides. A lot of people do those 2 steps in one, and that's okay, as long as you get to here. I need to see that step. And then divide both sides by 19. And once again, with a good scientific calculator, you should be able to run this to prove that both sides are the same. On the test, if the question says show the check, you have to show it to get the mark. But if you have enough time, you can check every question just to see if you're doing it right. So again, for this one, I actually think I would just run it through my hand calculator. Just punching buttons here. And remember that we learned earlier this year how to do, oops, we learned how to do button punching on the calculator. So my entries would look like this. I would go 5 times, this is me punching buttons, remember, open a bracket, 3 times 13, fraction button, 19, minus 1, close the bracket, and then hit equals. And I should get what the two sides are going to be equal. So I'll just run that 5 times, open a bracket, 3, oops, start that over, 5 times, open a bracket, 3 times 13 over 19 minus 1, close brackets, and hit equals. Okay? When you do that, you should get 5 and 5/19. And if you do that for the other side of the equation, you'll get the same fraction, proving that you've got the right answer. So there's the first type 4 equation that we looked at. Then we did type 4 equations where you have x on both sides and you have brackets and you have fractions. The way I would approach this one is, again, to pick my lowest common denominator, which in this case is 6, and I'm going to times both sides of my equations by 6. What that's going to leave me with is a 3 times this bracket and a 2 times this bracket, which I would simplify down to that. Some people might do skip this step and go right to here. If you're comfortable doing that and you're getting the right answer consistently, I don't mind that. And from there, I would minus 4x from both sides and minus 9 from both sides, and x would equal 11. Quick check to see if we've got the right answer. That would be 1/2 times 11 plus 3 equals 1/3 times 22 minus 1. And 11 plus 3 is 14. 1/2 of 14 is 7. And 22 minus 1 is 21. 1/3 of 21 is 7. Correct. Please notice I actually just did bed mass on each side. I didn't move things from one side to the other. You don't do that when you're doing a check. So there we go. That's how you would do a question like that. Okay, moving on. We called the method that I just used the I hate fractions method because we got rid of the fractions, again, by timesing everything by the common denominator. What that looks like in this question is a little different than what it looks like in the last question. See, the last question had these brackets, so I think of this as one number, that is one number. So I just had to times this 3 by the first number and then the second number. When there's no bracket involved, when I use my I hate fractions method and use my common denominator of 6, I have to remember to times every term in the expression by 6. Every single one of the 1, 2, 3, 4 terms gets times by 6 this time because I have to think of them as separate numbers. They're not grouped together as brackets, so I think of this as one number. These are 2 separate numbers this time. So this is 3x plus 18, 4x, and 6. So I'd minus 4x from both sides. And I'd minus 18 from both sides. And x would be 24. I won't bother with the check on this one. You can try it yourself if you like. If you don't mind working with the fractions, here's the same problem, but I'll actually work with them this time. I'll minus 3 from both sides, first of all. Okay, now I got to collect the like terms, so I'm going to have to minus 2/3. And remember, I still need a common denominator to do that. The common denominator of 2 and 3 is, of course, 6. So 1/2 is 3/6. 2/3 is 4/6. And that, of course, then would be negative 1/6 x equals negative 4. Some people are confident enough with fractions that they could probably skip this step. Make sure that you get to this step though and make sure that you do it right. And then I would divide both sides of the equation by -1/6, which is the same as timesing by -6, which again gives me the same answer I got last time of 24. So that's the two methods you can use for these type 4 equations. Then we took a quick detour into cross multiplying, starting with this type of equation. Remember that this is just information. It just tells you that no matter what you do when you solve for this x, there's no way it can be a 0, since you can't divide by 0. But the way that it solves is pretty simple. You just times both sides of the equation by x and divide both sides of the equation by 4, or consider it a cross multiply. The negative 36 stays where it is, but the 4 and the x switch spots, so x is -9. From there, we moved on to cross multiply equations that had ratios on both sides. So again, I'd move the 12, making 24/5. And then we had some where the x was on the bottom, which means I have two moves. The x and the 5 switch spots, so the x is here now. The 2 goes up and crosses and multiplies by the 12, and the 5 ends up where the x was, and I end up with, again, 24/5. So we use that idea here in type 4 plus equations, we called them, where instead of thinking common denominator, I can just do a cross multiply. So this side ends up being 2 times 2x minus 1, and this side here ends up being 3 times x plus 3. Notice I need the brackets and distribute. And then I minus 4x from both sides. I minus 9 from both sides. I divide both sides by -1. And if that equation looked familiar, it's really the exact same one I did a minute ago. Notice that these two equations are exactly the same. Think about why that is. Then we, of course, went into 5 types of word problems. And if you go on my homework online page, I have video examples of each of these types of word problems. There's the comparison problems where you compare plan A equals plan B for cell phones or wedding planning. Then there's the similar triangle problems, number problems, geometry problems, age problems, and coin problems. Expect for sure 2 or 3 of these on the next test, and then probably the ones we don't get to on this test we'll put on the next test. And one last little thing, don't forget we also looked at this rather weird situation. Sometimes you can't solve equations because they're unsolvable. For example, if I look at this rather unassuming equation and I do what I usually do, which is distribute the 2, I get something rather odd happen. When I minus 2x from both sides, I end up with no more x's to solve. Remember that this is telling me that the original equation was unsolvable, but this is a true statement, so it's telling me that x could be any number you like. Try it. Plug any number you want in for this x, and you'll get a true statement. Maybe another way to show that is to show that if I go, of course, minusing 2x from both sides, 2x minus 2x is 0 x's. Okay? And think about it. If 0 times some number minus 6 is -6, well, that x really could be any number because any number times 0 will still make 0, and 0 minus 6 does equal -6. So x really could be any number. Over here, I'm going to do the same thing. I'm going to distribute. Then I'm going to do what I usually do, minus 4x from both sides. Unfortunately, again, all the x's go away. But that leaves me a stranger looking result than this was. This was a true statement. This one is completely false. -12 doesn't equal 7. So what that's saying to me is that there is no number in the universe that'll make that true. So therefore, x has no solution set possible. One of the questions on the test will ask that you know the difference between this type of unsolvable and this type of unsolvable. Good luck, everybody. One last thing. Let's remember that there is some polynomials on this test. If you think you're good with the polynomials, you can stop the video right here. But as a quick refresher, remember that there's some terminology you have to know. You have to know the words variable, constant, coefficient, monomial, binomial, trinomial, and just what a term is. Then, of course, you have to be able to collect like terms. Make sure that you can do that. 1x squared plus 1x squared is 2x squared. 5x's add -2x's is 3x's. And 3 plus 7 is 10. From there, we then group them together as binomials. As trinomials. Can you add 2 trinomials? That for sure will be on this test coming up again. So 2x squared plus 1x squared is 3x squared. -3 plus 5 is 2x, and negative 4 plus negative 2 is negative 6. Remember that these brackets, when I'm adding, don't really mean anything. They are, however, meaningful when I'm subtracting. Remember that the key to subtracting, and this was not done well by a lot of you on the last test, is to take an extra step and change this to add the opposite. So I'm still adding all these terms, but I'm adding the opposite of those terms. So 2x squared minus x squared is 1x squared, negative 3 minus 5 more is negative 8, and negative 4 plus 2 is negative 2. Finally, the last two things you might see on this test are the multiplying and dividing of polynomials. Remember that this is a distribution, so that would be negative 6x squared because of the x times x, plus because of the negative times the negative 8. And when you're dividing, you distribute as well. So this would be 5x cubed divided by 5x would be 5, whoops, no it wouldn't. It would be x squared. Negative 10 divided by 5 is negative 2, and x squared divided by x is 1x. And don't forget that when a number divides by itself, it doesn't leave a 0, it leaves behind a 1. So that's the polynomial facts and skills that you should have at your disposal. And that's about it. If you can do everything that we've done in this review, you will ace that test. Good luck, everybody.